We'll move to the next topic. So yesterday we have discussed about the properties of the acids, and now today we'll be starting with the properties of the bases. So when we discuss about the properties of an acid, we notice they are salt, they contain the hydrogen atom. When they react with the bases, they form the salt and the water. When they react with the metal, they form the salts and they release the hydrogen gas. We discussed about the neutralization reaction also. So all these things we have discussed in the acid topic. Now coming to the bases, they are the substances which are bitter in taste. So when we taste them, they will be bitter, and they are soapy also. So like daily we are taking the bath, right? So when we touch the soap, we feel like it is like a little sticky. Same way, when we touch the bases also, we feel like they are a little soapy to touch. And if these two properties are present, then what do they contain? They contain bases in it. They contain bases in them. So bases, they are the substances which are bitter in taste and they are soapy to touch, and they contain bases in them. Now, as all acids were soluble, we have studied that all the acids are soluble. Like that, all bases are not soluble in water. So we cannot dissolve the bases in the water. And if the bases which are soluble in water, so those bases are known as alkalis. So if the bases, they are soluble in water, then they are called as alkalis. So now we have two types of bases basically. If they are soluble, then they are alkalis. If they are not soluble, then they are the normal bases. Clear, Varshit and Kritvik?
Yes, ma'am. Yes, ma'am.
Yes. So hence, by this statement, we can conclude that all alkalis are what? All alkalis are bases. But all bases are not what? All bases are not?
Alkalis.
Very good. All bases are not alkalis. Now, why we are saying that all bases are not alkalis? Because they cannot be dissolved in the water. Some bases cannot be dissolved in water. That is why we said that all alkalis will be the bases, but all bases will not be the alkalis. Then the next point, bases are compounds which contain oxygen or oxygen along with hydrogen. So in the case of acid, we have discussed that they should have compulsory hydrogen. But in the case of the bases, two conditions are there. The first condition, either they should have only oxygen, and the second condition, or they should have the oxygen with the hydrogen. So either only the oxygen or oxygen plus hydrogen, these two should be there. So in the acid, they should have the hydrogen, whereas in the bases, they should have either the oxygen or the oxygen along with the hydrogen can be there. Now, a base that contain oxygen is called an oxide. So what do we call them? So if any base, if it has what? It has the oxygen in it, we call them as the oxide. Can you give me the example of it? Like any example where the base contain oxygen? No?
Soap is a base.
No. I'm talking about the example in the sense like any chemical name. No, okay, I'll tell you. So here I said a base that contain oxygen. That base we will be calling as oxide. Like for example, MgO, right? MgO is what? A kind of base. So this O contains what? What's the name of the O here?
Oxygen.
No, not oxygen. In the case of the base, the oxygen will be changed into the what name they will change into?
Oxide.
It will change into the oxide. And that is why the name of this MgO becomes what? It is magnesium
Oxide.
oxide. Clear? So when you are going to use O with along with the base, it will be oxide, not the oxygen. So if you write oxygen, that will be magnesium oxygen. No, it is wrong. So wherever any base has oxygen in it, we should write as the oxide. So the complete name will be magnesium oxide. Fine. Now, like we have the another example, PbO. Do you know what is the name of Pb? No. It is called as lead. Like in your pencil, you have inside black color with which you will be writing, right?
Ma'am,
So,
graphite.
yeah, graphite, right. So the name will be called as lead oxide. Fine. So any base which has oxygen in it will be called as the oxide. So these are the few examples of it. Now moving to the next thing, as we have discussed, two conditions are there. Now in the first condition, this is the first condition where base contain the oxygen. Now in the second condition is where base contains oxygen along with what will be there along with oxygen?
Hydrogen.
Very good, hydrogen. And then that is called as hydroxide. If only oxygen is present, it is called as oxide. And if oxygen and hydrogen both are present, it is called as hydroxide. Now, any chemical name you have learned?
Sodium hydroxide.
Very good, Varshit. Sodium hydroxide. Do you know the formula of sodium hydroxide? What is a symbol for sodium?
Ma'am, NaOH.
Very good. So Na is actually the name of or the symbol for the sodium Na, and hydroxide stands for OH. So NaOH, sodium hydroxide. Now, if I give you the other name like KOH. Now K stands for
Potassium.
very good, Kritvik. Potassium, and what OH stands for?
Hydroxide.
Hydroxide. Okay,
Yes, ma'am.
hydroxide. So I hope children now you're able to understand how to make the names also. Fine. That is the reason I told you that slowly and gradually we'll be learning to make the name. So these are the few points which you should always remember starting from class 7 till class 12, that whenever any acid is there, it should have the hydrogen in them. Whenever any base is there, either they should have oxygen or they should have the oxygen along with the hydrogen. If only oxygen is present, then it is called as the oxide. If oxygen along with the hydrogen they are present, it is called as hydroxide. Yes, Kritvik?
Yes, ma'am. Magnesium hydroxide is also there.
Yeah, it is there. It is there.
Okay.
So MgOH2, but you know that depends upon the valency also. So you will be learning slowly and gradually about that. So magnesium hydroxide is there, but we do not write it as MgOH. We do not write it as MgOH. This is wrong. We always write that as MgOH whole twice. So it's basically about the valency to maintain the number of electron. It is written like this. Same way it is calcium hydroxide. We write it as like this. All right. So few things are there. We'll be discussing as we are coming to that. Now, okay. So these two things are very clear. We'll go to the next one, which are the properties of bases. So talking about the properties of bases, the first property, we know that they are bitter in taste. So when we taste them, they are bitter. Second thing, they turn red litmus to blue litmus, blue color. Then They possesses a slippery touch. As we have discussed, what do they have? They have a slippery touch with them. Slippery or the soapy touch is there. Then, like the acid, they can conduct the electricity or not?
Yes.
Yes, right. Same way, the solution of bases also can conduct electricity in water. So they can also conduct electricity in water. So basis solution, they can conduct electricity in water. Then next one, strong bases. Like we have the strong acid, we have the strong bases also. So those bases which are strong, like caustic soda. Caustic soda is basically your sodium hydroxide only, okay? So caustic soda and caustic potash, that is KOH. So caustic soda is your NaOH, which is sodium hydroxide, and caustic potash is your KOH, which is potassium hydroxide. They both are corrosive in nature. So what do? They destroy or they corrode the surface, or they corrode the container wherever they are kept. Then next, very, very important properties, two properties we are going to learn. So bases react with acids to form a salt and water. So what happens in the case of acids? When acid reacts with the bases, what do they form?
Ma'am, same salt and water only.
Correct, Varshit. So when acid were also reacting with the bases, they were forming salt and water. Same thing is happening in this case also. When bases are reacting with an acid, they also form salt and water. Now let's see a few examples, or maybe one or two examples. For example, now we have, suppose, NaOH plus we have HCl. What is NaOH here?
Sodium hydroxide.
Yeah, it is sodium hydroxide. What is HCl?
Hydrochloric acid.
Hydrochloric acid. Now, we know sodium hydroxide is what? It's a base. And we have said when base react with an acid. So here we have the acid. Now these two, they react together. And what should they form? They should form salt and they should form water. Now this NaOH and this hydrochloric acid, what do? They both will join together and they form NaCl and they form what? Water. What is NaCl here?
Sodium chloride.
Very good, Kritvik. Very good, Anubhav. So it is sodium chloride, which is our normal salt, the salt which we mix in vegetables or making curry and all. That is called as sodium chloride or the table salt. It is also called as table salt. So in this section, what happened? The base was there, the acid was there, and both reacted together. They formed the salt called as the sodium chloride, and they also release the water, which is H2O. Now, another example we'll see NH. Yeah,
Ma'am, then what is the rock salt?
what is the
Rock salt, ma'am, rock salt.
rock salt? Is another type of the salt. It is not the table salt. So,
Okay.
rock salt is basically we will be getting, near to the oceans and all. From there, they will be digging and they will be getting it.
Okay, ma'am.
Okay, so NH4OH plus HCl. Now, I'll tell you the name of the NH4OH. NH4 is basically ammonium. Now, what is OH here? What will be the name of the OH?
Sorry.
Hmm?
Hydroxide.
Correct. So, hydroxide. Now, what you need to keep in mind always, that NH4 stands for ammonium. So, you know now NH4 is ammonium and OH is hydroxide. So the name of the compound will be ammonium hydroxide. And this HCl is what?
Hydrochloric acid.
Hydrochloric acid. Very good. So it is hydrochloric acid. So this ammonium hydroxide is a base and this HCl is what? It is an acid. Right? Now both they will be combining together and what should they form? They should form a salt. And here what do they form? They form a salt known as what? What is NH4 here?
Ammonium.
Ammonium. And what the Cl stands for?
Chloride.
Chloride.
No, wait. So there is a difference, it depends upon the compound, what they are mixing with. So here the Cl not stands for chlorine, it stands for chloride. And why we say it is a chloride? Because this chlorine will be releasing the electron. They will be giving the electrons to the other compound. That is why it is chloride, not chlorine. Fine. So, yes, Kritik?
Ma'am, I said chloride only, ma'am. It's not
Okay.
fluoride.
Okay. Then Kritik, it is fine. If you have said chloride, because I heard it chlorine, then perfectly, absolutely right. So it is chloride, Cl. And here the Cl will be minus actually, because they give the electron and that is why they become negative in charge. So ammonium chloride, this is what? It's a kind of a salt, right? So that is how the reaction occurs between the bases and the acids. Now coming to the next property. In the next property, the bases react with metal. Now, when bases react with the metal, what should they form? In the case of the acid, what they formed?
Mm,
In the case of the acid, what they should have formed? Salt and hydrogen, right? So when acid was reacted with the metal, they formed the salt and hydrogen. Same way, when bases also react with metal, they form the salt and hydrogen gas. So this keep in mind whenever the acid or base they react with the metal, they will be forming the salt and hydrogen gas, and whenever the acid reacts with the bases, they form the salt along with the water. Okay, so we'll see the few examples or example like NaOH. We know NaOH is sodium hydroxide here, which is a base, sodium hydroxide, and it is a base. Now what we have taken a metal called as zinc. So zinc is a metal. Now these both NaOH and zinc, they will be reacting together and they form a salt which is Na2ZnO2, and this is called as sodium zincate. It is called as sodium zincate. Have you ever heard this word, sodium zincate?
no,
Okay, so you should know sodium zincate is basically a kind of a salt which will be used to, conduct the electricity. In a very simple language, the electricity which is being used by us, that will be formed with the help of the sodium zincate. So, and how it is formed? It is formed with the reaction of the base and with the reaction of the metal. Na2ZnO2. And you might have heard like the people or the doctor or sometimes at your home also, you might have felt that if some person has the low amount of zinc in the body, so what the doctor they will be doing, they will be giving them the medicines, and these medicines contain what? They contain the sodium zincate. So basically, to increase the amount of zinc in our body, the doctor will be giving a medicine called as sodium zincate. That is what it is being used. If the level of zinc is low, then it is used by us, so that we can increase what? We can increase the amount of zinc in our body. Otherwise, it is used for conducting the chemical, and they release the hydrogen gas as well. So this is how the reaction occurs. So any doubt you have?
Moment.
Now going to the next one. Next, what do all bases have in common? Now you should answer me. What they have in common?
Hydroxide.
Hydroxide? Yes. Hydroxide or the oxide. So either they should have the hydroxide or they should have the oxide in it. So when we dissolve a base in the water, what do they form? They form the hydroxide ions, which are written basically as OH minus ion. Like for example, when NaOH it mixes with water, it form Na plus and it form OH minus. So sodium ion will be formed and this is hydroxide ion will be formed. So whenever they have common is the hydroxide or the oxide. Whenever the base react with the water or it mixes with the water, they form the hydroxide ion. Example NaOH, which forms the Na plus OH. Now, types of bases. Like we have discussed yesterday about the types of an acid. On the basis of the strength, we have the two major type of it. What will be those two?
Strong bases and weak bases.
Very good. So we have just two types of bases: strong bases and weak bases. Wait, weak bases. Now, how can we define the strong bases?
And more amount of hydroxide.
Correct. But when they will be forming the large amount of hydroxide? What we should mix with them?
No water.
Correct. So you should answer completely. Your answer is very correct, but we should add them water also. So a strong base is a base which completely ionizes in water. And because of this, what they do? They produce a large amount of which ion? Hydroxide ion, which is OH minus ion they will be producing. And when we talk about the weak bases, they will be partially ionizes. And since they are partially ionizes, what happened? How much amount of the hydroxide ion they will be forming? They will be forming small amount of hydroxide ion, which is O minus ions. Clear?
Yes.
Yes, ma'am.
Okay. So we'll see the example for both, as we have discussed already. NaOH, which is sodium hydroxide, is a strong base, which is also called as what? Which is also called as caustic
Caustic
soda.
soda.
Then the second one is KOH. What is the name of KOH?
Potassium hydroxide.
Correct. And what is the other name of potassium hydroxide? It is called as caustic potash. Potash. All right.
Yes, ma'am.
Now moving ahead with the third, the example of the weak bases. Now the first weak base is the magnesium hydroxide. Magnesium hydroxide, which is MgOH whole twice. And the second one is ammonium hydroxide. Now tell me the formula of ammonium hydroxide.
No.
NH4OH.
Correct. It is NH4OH. Very good. So these are what? These are the differences between the strong and the weak bases.
Ma'am, can I
So any doubt you? Yeah.
Ma'am, is there any base which is king of all base?
No, not like that. No.
Okay.
So we'll go for the next. Before that, the bases video was remaining. I'll play from the bases.
They are bitter in taste. They have a wide range of applications in our daily life. They have hydroxide ions present in them, and acids have hydrogen ions present in them.
Sir, can you please explain in detail?
When acid dissolves in water, it releases hydrogen ions. Acids have hydrogen in them, like HCl, hydrochloric acid, HNO3, nitric acid, H2SO4, sulfuric acid, etc.
Sir, do bases have more hydroxide ions in them?
Base is any compound that yields hydroxide ions, OH, when dissolved in water. Example, sodium hydroxide, NaOH, magnesium hydroxide, MgOH2, potassium hydroxide, KOH.
Sir, can you please give some examples of bases?
Limestone, baking soda, washing soda are all bases.
Does soap also have base?
Yes, soap nut is a natural soap which has a base.
Mother uses soap nut to wash her hair.
Yes.
Children, can you tell whether there are acids or bases in toothpaste, chalk piece and spinach?
Sir, some items are sweet. Do they have acids or bases in them?
They have neither acids nor bases. Some substances have neither acids or bases.
What will happen when acids and bases get mixed?
Rinku, when acids and bases meet, generally salts are formed along with water.
Oh, I see.
The salt we consume is formed due to combining of hydrochloric acid and sodium hydroxide.
Very interesting. Sir, there must be some indicator to determine whether a substance is having acid or base.
We cannot taste each and every substance to determine whether it contains acids or bases. The time is over now. Let us talk about it tomorrow.
Children, we have come to know the difference between acids and bases. While acids dissolve in water, most bases do not dissolve in water. In the next video,
So that was the video regarding the bases. We'll go to the uses of bases now. Uses of bases. The first use is they are used as a common reagent in various in various industries. So several industries, they will be using these bases as a common, you can say, like just like an ingredient, they will be using it. Then calcium hydroxide is used for white washing of buildings. You might have seen that before applying the paint, what they will be doing, they will be applying a kind of white wash. So that white wash is basically made up of the calcium hydroxide, and which is a kind of base. Then sodium hydroxide is used for manufacturing soap. So basically the soap which we use generally contains the sodium hydroxide in it, and it is also used for manufacturing paper. Then in the textile industries, textile is basically your cotton industries or the jute industries. Your cloth making industries are the textile industries. Then ammonium hydroxide is used for manufacturing fertilizers, plastics, and dyes. And last one is milk of magnesia. Have you ever heard this word? Milk of magnesia?
Mom, I heard, but I don't know the meaning.
Okay. So milk of magnesia is basically the other name of magnesium hydroxide. So other name of magnesium hydroxide is milk of magnesia, and it worked as an antacid. So basically when the acidity will be there, what we will be taking? We'll be taking the Eno or some other tablet like this. So those Eno and other tablet, they contain what? They contain the milk of magnesia, which has base in it. So already acid was present in the stomach. Now milk of magnesia, which is base, we have taken into the body, and because of which the neutralization will be there. So milk of magnesia is the magnesium hydroxide, which is an antacid. And this antacid, they will be used to reduce acidity in stomach. So acidity will be reduced in stomach due to this milk of magnesia. So these are the certain uses of it. So calcium hydroxide is used for whitewashing of the building. Sodium hydroxide is used for making the soap, also for making the paper, textile and all. Ammonium hydroxide is used for manufacturing fertilizers, plastics and dyes. Magnesium hydroxide, which is called as milk of magnesia, is used as an antacid just to relieve the acidity problem in the stomach. So that's about the basis properties as well as the uses of it. So we'll just go through all the properties once again. So bases, they are the substances which are bitter in taste. They are soapy when we touch them. They all are not soluble. Some are soluble, some are not soluble. And if they are soluble, they are called as the alkalis. All the alkalis are bases, but all the bases are not the alkalis. They contain either the oxygen or they contain oxygen along with the hydrogen. And if they contain the oxygen, they are called as oxide. If they contain both oxygen and hydrogen, they are called as hydroxide. Then properties, bitter in taste, they turn red litmus to the blue. They have slippery or the soapy touch. They conduct the electricity in water. Strong bases, they are corrosive in nature. They react with the acid to form salt and water, and they react with the metal to form the salt and the hydrogen gas. What do they have common? They have the hydroxide in the common. Types of bases, two types, strong bases and the weak bases. Strong bases, they will be completely ionized in the water, because of which large number of hydroxide ion will be produced, and weak bases, they will be partially ionized, because of which the less number of hydroxide ion will be produced. Example, NaOH and KOH, they are the strong base, whereas magnesium hydroxide and ammonium hydroxide, they are the weak base. And that is the reason that milk of magnesia, which is magnesium hydroxide, we can drink it because it is a weak base. Then uses we have discussed: calcium hydroxide for whitewashing, sodium hydroxide for the manufacturing of soap, paper and textile industry, ammonium hydroxide for the for the manufacturing of fertilizers, plastic and dye, and milk of magnesia as an antacid. So I hope you are clear with this topic.
Yes, ma'am.
And
Yes,
you know, these are like certain basic topics which are going to help you a lot in your higher classes. 8th, 9th, 10th, all the classes have the same chapter, acid, bases, and salt. So make sure that you should, you know, understand it. I don't want you to mug up. You should understand it. If it OH is there, what do you mean by it? If it is H is there, what do you mean by it? If only O is there, what do you mean by it? Then apart from that, which is strong, which is weak, white is strong, white is weak. Then all these things, and if the acid react with the bases, what happens? If the acid react with the metal, what happens? So all these reactions are going to help you a lot in your higher classes.